Picture this. It's 4 in the morning. You're standing in the yard, and it's probably raining. Maybe it's freezing cold. It's always one of the two, right?
Always.
You've got a reefer unit in front of you. You're running a pre-trip test. Coffee in one hand, checklist in the other, and you just want to get this thing dispatched so you can go back inside.
Yeah, get back to the warmth.
Exactly. The engine's humming. Everything looks green. And then just silence. The unit shuts down, you look at the display, and there it is, alarm code 02.
The dreaded shutdown alarm.
Yep.
You know, that silence is the loudest sound in the world when you're in a hurry.
It really is. And here's the kicker. If you were just driving down the highway, alarm code 02, that's just a check alarm. You know, something to note for later. But right now, in a pre-trip, it becomes a hard stop.
That truck is not going anywhere.
And this is usually the moment where a lot of guys they grab a sensor, rip the old one out, throw the new one in, and just cross their fingers.
We call those parts changers. And look, I get it. The pressure's on, the dispatcher's on the phone, but just swapping parts without understanding the logic behind it is, well, it's a dangerous game.
Expensive, too.
Very expensive. And half the time, it doesn't even fix the root cause. Today, we're not doing that. Today, we're going to be technicians.
I love that. We are going to do a proper deep dive. We're unpacking alarm code 02, check evaporator coil sensor. But we're going beyond just the manual. We want to get into the wiring, the physics of why they fail, and the hidden logic the controller uses.
It's fascinating because on the surface, it's just a temperature sensor, a little piece of plastic and wire. But the way the controller monitors it, the validity checks it runs,
yeah,
it's actually pretty sophisticated. It tells a story if you know how to read it.
Okay, so I'm the trainee today. I've got my multimeter, I've got the schematics, but I don't have your years of experience. I want to know not just what to do, but why I'm doing it.
That's the key. That's the only way to really troubleshoot. If you get the why, the how just falls into place.
So let's start with geography. I walk up to this unit, I open the doors. Where does this troublemaker live?
Okay, you're going to find this sensor physically mounted on the evaporator coil header plate. That's its home.
Okay.
It's usually tucked away, strapped to the piping. And before you even touch it, you need to know what kind of sensor it is.
My notes say it's an ungraded sensor. That sounds important, but I'm not totally sure what that means.
That's maybe the most important thing to know right at the start. Ungraded means it does not require calibration. I can't tell you how many times I've seen techs wasting hours with ice baths and reference thermometers trying to calibrate this sensor.
So you can't just go into a menu and tweak it a few degrees?
No, absolutely not. It's a sealed unit. If it's reading wrong, it's either broken, it's installed wrong, or the wiring to it is shot. Knowing you can't calibrate it saves you so much time.
Okay, that clears the table then. No calibration tools needed. So we're at the evaporator coil. Let's talk about the nervous system. How does this thing actually talk to the brain of the unit?
Right, because it's usually not the sensor itself that failed, it's the connection. The sensor is just the fingertip, the wiring is the nerve. It's a simple 2-wire circuit, but the specifics matter when you're chasing a break with a meter.
So let's map it out. For the listener who's maybe got the schematic open in their mind right now, what are we looking for?
Okay, visualize the harness. The positive wire is labeled CTP01. That's your plus side.
CTP01. Got it.
It connects to the base controller at a really specific spot. The 35-pin sensor connector, we call that J3 on the schematics.
J3, that's the big one, right? The nerve center for all the sensors.
That's the one. G3 is the main highway for all that data coming into the brain. So that positive wire, CTP01, goes into J3 at pin 25. And inside the harness, that connects to the blue sensor wire.
Okay, holding that in my head. Pin 25 is blue. Positive. What about the negative?
The negative is CTN01. It also runs to J3, but it lands on pin 14. That connects to the brown sensor wire.
So just to lock that in, because this is the bread and butter of troubleshooting, pin 25 is blue, positive. Pin 14 is brown, negative.
You've got it. And remember, these are hardwired. It's a dedicated loop. If you've got an open or a short, it's happening somewhere along that blue-brown highway.
I like that, the highway. So before we get to the alarms, let's talk about installation. You mentioned a lot of failures are, well, self-inflicted. That sounds frustrating.
Oh, it is. It's heartbreaking.
Yeah.
You see a brand new sensor fail in a few months because of how it was put in. You have to remember, the environment inside a reefer is brutal. It's hot, it's freezing, it's wet. Moisture is the #1 enemy.
It wants to get inside the sensor shell.
Relentlessly. It wants to get in, corrode the element, and throw off the resistance. But the manual gives us a golden rule for installation that I swear half the industry just ignores.
I saw this and I underlined it. It says, mount sensors with the barrel up and the wires down wherever possible.
Barrel up, wires down.
It sounds so simple, right? Almost like it shouldn't matter.
Yeah, I mean, it's a sealed sensor. It looks waterproof. Why does gravity matter? Because nothing is perfectly sealed forever. Not with the expansion and contraction in these units. Think about the physics. If you mount it with the wires pointing up, any condensation, any water, runs down the wire and pools right at the entry point of the sensor shell.
Ah, so it just sits there.
And then the unit heats up, cools down. That thermal cycle literally sucks that moisture inside. It's capillary action. You're basically funneling water into your own sensor.
But if the wires are pointing down,
the water just drips away. You're using gravity to your advantage. It's such a simple visual check. When I walk up to a unit with a history of sensor issues, that's the first thing I look for. Wires up. I already know the probable cause.
that is a pro tip. Wow. Diagnose the install just by looking. Okay, so let's say we did everything right, but the display is flashing alarm O2. The source material talks about two types of failures: hard failures and soft failures.
This distinction is critical. If you walk away with one thing today, let it be this. Not all alarm O2s are the same, and you have to troubleshoot them differently.
Let's start with hard failure. Sounds dramatic.
It is. A hard failure means the sensor is reading something physically impossible. The controller looks at the data and just says, nope, this isn't real. I reject this.
What are the limits? How extreme does it have to be?
There's a high limit and a low limit. The high limit is 200 degrees Fahrenheit or 93 Celsius.
200 degrees? Inside a reefer? That's oven temperature.
Exactly. Unless the trailer is literally on fire, the evap coil is never 200 degrees. So if the sensor sends that signal for more than 10 seconds, the controller flags a hard failure.
And what does the screen show? Does it say 200F?
Nope, the computer knows that number is garbage. You'll just see dashes, 3 dashes. That's the computer saying, I have no idea what the temperature is, but it's way out of range.
Okay, dashes mean we're off the map. That's the high side. What about the low?
The low limit is minus 50 Fahrenheit or minus 46 Celsius. Same deal. If it reads that low for 10 seconds, boom, hard failure. Dashes on the screen.
Is there ever a time where minus 50 is okay? I mean, these things get pretty cold.
Good catch. There is one very specific exception. If the unit is running a low evaporator coil temperature demand defrost, then it ignores that check. But in normal operation, minus 50 usually means an open circuit.
So hard failures are the extremes. Dashes on the screen, pretty easy to spot. But the soft failure, that sounds trickier. It sounds like the sensor is gaslighting the machine.
That's a perfect way to describe it. A soft failure is when the sensor is lying, but the lie is plausible. It's subtle.
So it's still within the range.
Exactly. It's not reading 200 degrees. Maybe it's reading, 40 degrees when it should be 10. Or it's jumping around dash 10 to 30 to 5 in just a few seconds. The behavior is wrong, even if the numbers aren't at the hard limits.
And this also triggers alarm O2.
Yes, but it usually brings a friend along with it. You'll often see alarm code O2 paired with alarm code 13.
Alarm 13, that's sensor calibration check.
Correct. When you see O2 and 13 together, that's the controller telling you, hey, the sensor isn't dead. I'm not getting dashes, but its data is garbage. It's drifting. It's failing my logic check.
It's amazing that the system is smart enough to know the difference between I'm disconnected and I'm just unreliable.
It's vital for diagnostics.
Yeah.
A hard failure dashes. I'm looking for a cut wire or a loose pin at J3. A soft failure with alarm 13. I'm thinking moisture intrusion, something causing the resistance to fluctuate.
Okay, so let's say we have the alarm. I think I fixed it. I go to the keypad, I hit clear alarm.
And this is where the system gets really clever.
Yeah.
You can't just clear it. The system performs a reality check, a validation test, right when you hit that button.
It doesn't just take my word for it.
No, it trusts, but it verifies. It basically holds a meeting with 3 sensors: the return air sensor, the discharge air sensor, and our problem child, the evaporator coil sensor.
It compares them to each other.
It does, and has a very strict rule, the 30-degree rule.
The 30-degree rule, break that down for me.
All 3 of those sensors, return, discharge, and evap coil, they must all read within 30 degrees Fahrenheit of each other. That's about 17 Celsius.
So they all have to be in the same ballpark.
Right. If the unit's been off for a bit, they should be relatively close. So if the return is 10 degrees, the discharge is 12, but the evap coil sensor is reading 55 degrees.
That's way more than a 30-degree difference.
And the system says, nope. It assumes the sensor is still inaccurate. It will not clear the alarm. Alarm O2 stays, and it sets alarm 13 again to tell you it's still out of Antical.
That is a brilliant safety feature. It stops you from sending a truck out with a lid of ice cream that's going to melt because the unit thinks it's cold when it's not.
Exactly. It forces you to actually fix the problem. And of course, if it's still reading dashes, it won't clear either. But that 30-degree logic is what trips people up. They replace the sensor and wonder why the code won't clear.
That's a good point. Maybe you just put a warm sensor from your truck into a cold unit.
You have to give it a minute, let the temperature settle. Don't panic if it doesn't clear instantly.
Okay, so we've covered the what and the why. Now, the tools. We started this saying we want to stop being parts changers. The outline mentions Service Watch and WinTrack.
This right here is the dividing line. An amateur swaps a part. A pro downloads the data.
Walk me through it. I plug my laptop in. What am I doing?
You open your WinTrack software, and you download the Service Watch data logger. This is the unit's black box recorder. It logs all the sensor data every few minutes.
And I need to be in the technician user level for this, right?
Absolutely.
Yeah.
And here's the secret sauce. You don't just look at the current temperature. You have to look at the conditions at the time the alarm was set.
Because the problem might be intermittent.
Exactly. It might be working perfectly fine right now while you're standing there.
Yeah.
But Service Watch freezes that moment in time. It'll tell you at 3 a.m. when the alarm triggered, the evap sensor dropped to -60 for 15 seconds.
And that tells me it was a hard failure, a momentary open circuit, maybe a wire rubbing on the frame.
Right. Or maybe you see the graph for the evap sensor looking like a heartbeat monitor, up, down, while others are flat.
And that's our soft failure, the drift.
And that gives you the confidence to replace it, even if it looks okay right now. You have proof. You aren't guessing anymore.
There's one more scenario in here that sounds terrifying, the Christmas tree effect.
Oh, yes. Every tech has seen this and had a moment of panic. It's a rite of passage.
This is when you see a whole list of codes, 02, 03, 04, 05, 06, 11, 12, 13. The whole board just lit up.
Exactly. You scroll, and it just keeps going.
My first thought would be the whole board is fried.
Right. Or it got struck by lightning. But just pause and think about it. What are the odds that 8 different sensors in different parts of the unit all failed at the exact same millisecond?
Pretty much zero.
It's basically impossible. So if it's not the sensors, what's the one thing they all have in common?
It goes back to where we started, the J3 connector.
That 35-pin connector. It's the choke point.
Yeah.
If that connector is loose or not fully clicked in or has a bit of corrosion, it breaks the connection for all of those sensors at once.
So if you see the Christmas tree, don't order 8 new sensors, check the plug.
Check the plug. Unplug it, look for corrosion, plug it back in until it clicks. 9 times out of 10, all those codes will just vanish.
That is huge. That's the kind of knowledge that saves a fleet thousands of dollars and days of downtime.
It is. It's about understanding the system's architecture, not just reacting to symptoms.
Okay, let's do a quick recap. I want to make sure I have this all down in my trainee notebook.
Let's do it.
First, anatomy. evap coil sensor. It's ungraded, so don't try to calibrate it.
Correct. If it's bad, it's bad.
The wiring highway. Pin 25 is blue, that's positive. Pin 14 is brown, negative, all coming from the J3 connector.
The nerve center. Yep.
Then the golden rule of installation.
Barrel up, wires down, let gravity be your friend.
Then the failures. Hard failure is the extremes, over 200, under -50, you'll see dashes. Soft failure is the drift, usually with alarm 13.
And don't forget the clearing logic. The 30-degree rule. The system has to agree with itself before it lets you move on.
Right. And finally, the ultimate tool, data. Use WinTrack and Service Watch to see what happened when you weren't looking.
That's the most important part. The data removes the guesswork. It turns I think into I know.
You know, what strikes me about all this is how sophisticated the logic is. We think of these as just big freezers, but the controller is constantly running these validity checks. It's not just taking data blindly, it's questioning it.
It is. It's designed to be skeptical because it knows things can fail. So it cross-references, it's checking its own work all the time.
And that leads me to our final thought for the listener. The system is designed with this fail-safe. If 3 sensors don't agree, it assumes one is lying and it refuses to move forward. It forces you, the technician, to verify reality.
It prioritizes truth over convenience. It forces you to stop and think.
Exactly. And it raises a question for us, not just in this job, but in how we diagnose problems in general. Where else do we ignore the consensus of the data just to get a quick fix? Are we looking for that 30-degree agreement, or are we just trying to clear the alarm, close the ticket, and go home?
That's the difference between fixing a problem and just hiding it for the next guy.
something to think about the next time you see that red light flashing at 4 in the morning. Thanks for listening to the deep dive. We'll catch you on the next one.